So let's begin today's class. Assalamu alaikum everyone. All right. So what are we going to do today? We will revise and see the exercise of chapter number 2. That's it. And the last one, practice test. Law of conservation of mass. It will start at around 12:15 and 12:20. That is why I have started the class little bit earlier, 1 or 2 minutes earlier. Okay. So let's begin. So this was done. The blanks was done. MCQ was done of chapter number 2. We have the answers. Okay. And these are also the MCQs, second part. And we were doing this one. Okay. So what is the first question? So simple question, I think most of you have done this part. State the law of conservation of mass. You know, you are going to appear in the test today. And the second one is the law of definite proportion, law of multiple proportion, the third one. The fourth one, the law of reciprocal proportion. Reciprocal proportion is not included in the syllabus. We will not, okay? I repeat, question number 4 is not included in the syllabus. Question number 5. What is empirical formula? You know. What is molecular formula? You know. Let's have a very little brief revision of empirical and molecular formulas. See, molecular formula means actual formula of a compound, and empirical formula means the simplified, the shortest formula of a compound. For example, the most common example like glucose. What is the chemical formula of glucose? C6H12O6. This is its molecular formula. It is showing the actual number of atoms. Means we say that a molecule of glucose has 6 carbons, 12 hydrogens, 6 oxygens. So this is called molecular formula because it is showing the actual number. And if we simplify it, in this table we can cut 6. 6 1 the 6, 6 2 the 12, 6 1 the 6. So it will become, after simplifying it, it will become 6 1 the 6, 6 2 the 12, 6 1 the 6. This will be its simplified formula. This will be its empirical formula. Shortest formula of a compound. It only shows the ratio, not the actual ones. What is the ratio here? The ratio of carbon is 1, the of hydrogen 2, of oxygen 1. So this is the ratio. So empirical formula doesn't show the actual number of atoms, but a ratio of atoms. Okay? Clear? One more thing. Ionic compounds only have empirical formula, whereas molecular covalent compounds or molecular compounds, they may have empirical formula and molecular formula. One more thing, there are the compounds like carbon dioxide, molecular formula, and we can't simplify it further. So its empirical formula would be same again. It means there are the compounds in which molecular formula and empirical formula are same. One example, another example, water, a molecular formula, empirical formula same. Another example, H2SO4, same molecular and empirical formula. Okay? So this was a brief revision of empirical molecular. Let's see the next question. So what is the question there? I have to go there nearer to the laptop. Okay, you must be hearing me. Can any one substance have the same empirical and molecular formula? Yes. What is the answer? Yes. There are the possibilities that a substance may have same empirical and molecular formula. You can see the examples on the board. Clear? Carbon dioxide, water, H2SO4, this, and so on. Next question. What is the difference between empirical and molecular formula? Just told you. And when we were doing it in detail, I've shown the difference in these two on the slide. Like you can write the definition in one column. Molecular formula is the actual formula, and empirical formula is the simplified formula. Point number 2, it shows the actual number of atoms. It doesn't show the actual number of atoms, it shows the ratio. Only those students will be getting who know it. Yes. Because it's a revision, I'm not explaining it. I'm helping you out. I'm trying to increase your understanding level in these topics. Okay? So difference you know. Number 9, what is atomic mass unit? Everybody knows. Its definition is written, you know, I have given it in the assignment also, that what is 1 AMU, its value you know, it was given in the assignment. Now, the only other problem from this page that we have not done is this one, number 10. I'm sorry, number 11. Number 10, what is number 10? What is the question there? The value of atomic mass of carbon in the periodic table is taken as 12.011, but we write here 12.00. What does it mean? It means when we write, like we have used in finding the molecular masses and molar masses, I told you, you also know that the atomic mass of carbon is 12. But what is the question here? That we use 12.00, but in periodic table it's written 12.011. So what is the reason? Reason is this, that we take average atomic mass. We take average atomic mass. Now here I would like to introduce a new term. Told you earlier. Wait for a minute. Now, let me ask you a question. When you buy a fruit like oranges, or like apples, or like mangoes, my favorite. So everybody knows that their sizes, their masses vary. They are of different masses. Okay? Suppose I have got some mangoes, then all the mangoes are not of the same mass. right? But they are mangoes. Similarly, in chemistry, hydrogen, if we take hydrogen as an example, then all the atoms of hydrogen are not of the same masses. There are the chances they differ in terms of masses, right? Like we may have hydrogen in which the mass is 1, or we may have hydrogen in which we have mass 2, or we may have hydrogen in which the mass is 3. All of these hydrogen, because their atomic number is same, 1, 1, 1. What am I trying to show you here? That there are the possibilities that same element can exist in different masses. This property is called isotopes. Isotopes. Now, why are they same? Very typical question, very technical. Why are they same? Because they contain the same number of protons. Long time ago, I told you, number of protons present in the nucleus of an atom will define the name of that element. If an atom has 1 proton, we call it hydrogen. If there are 2 protons, we call it helium. If an atom has 3 protons, we call it lithium. So the number of protons give the characteristic properties of an atom that we call element. So all of these are same number of protons. It has 1 proton, 1 proton, 1 proton. That is why we call them hydrogen, but their masses are different. What is the question here? Same protons, but their masses are different. So these are called the isotopes of hydrogen. Similarly, we may have isotopes of oxygen. So you may see 815, 816, 817, and so on. These are the isotopes of oxygen. Or you might carbon 612, carbon 613, or carbon 614. So these are the isotopes of carbon. So what is the bottom line here? What is the point to be to remember? That atoms may differ in their atomic masses, though they have same number of protons. These are called isotopes. Okay? So isotope means same protons but different number but different masses. Isotope means masses of the same atom having atoms of the same element having different masses. I repeat, what do you mean by isotopes? Atoms of the same element having different masses, like mangoes of the same species but different masses, apples of the same species but different masses, hydrogen having same protons but different masses, carbon having same protons but different masses. All right? So this is called isotopes. Now there's a question in our book that they have chlorine. For example, what is the question there? Suppose we have an element A, one more thing. Whatever new thing related to the previous concept, very important, listen, very important, listen. whatever be the new thing that we will do today or tomorrow regarding or relating the previous concept will not be included in the test. New thing related with the previous topics will not be included in the test. Have you got this? Fine. It means this is just for your the completion of chapter number 2. This one. Is it clear? See, suppose we have two masses, an element A. Its number is 30. Suppose this element A is present in this room. So around 70% we find A30 and 30% we find A32. There's an element in this room A in which the percentage of 1 is 70 and the percentage of 32 is 30. And we have to find their average. Okay? So, how will we do it? A question like this, very simple, just telling you verbally, multiply the percentage by the number. 70 percentage means 70 upon 100 into 30. 30 upon 100 into 32. 70% means 70 upon 100. What is the mass here? 30. 30 upon 100. What is the mass here? 32. Solve them. What is the answer? 21. Solve here. These are the answers. Add these two answers. This will give you the average mass of this one. So if you add this one, it will become, it will become 30.6. So this is the average mass of A. Look at the board quickly. Suppose we have carbon 6, 12, 80%, and we have carbon 13, 20%. Then how can we find its average mass? 80% means 80 upon 100 multiplied by its mass 12. 20% means 20 upon 100 multiplied by its mass 13. Getting the answers over here, and then what would be the average mass? These answers would be added. This will give you the answer. Actually, there is no light in this room. Okay? Very little. So now see the next question. Question number 11. The atomic masses of 35 is 75% and 37 is 25%. So what will you do? 75 upon 100 multiplied by 35 and 25 upon 100 into 37. Adding the answers, we will get the average atomic mass. How many of you remember how many atoms are there in 1 mole of any substance? Correct, 6.02 into 10 to the power 23. So if 1 mole contains 6.02 into 10 to the power 23, then in question number 12, how many moles, how many atoms are there in 5 moles? Multiply 5 by 6.02, you will get the answer. So what is the answer? Just write the answer. No need to make any data solution, etc. You say 1 mole contains 6.02 into 10 to the power 23. 5 moles contain 5 multiplied by 6.02 into 10 to the power 23. Use calculator afterward. Okay? What is mole? A theoretical question. Mole, molar mass, find out the molar mass of sulfur dioxide. You know, how can you find molar mass of sulfur dioxide? Sulfur 32, oxygen 16 into 2, so its mass would be 64. Number 14 we also did on page number 23. Number 15, Avogadro number. It represents the number of atoms, molecules, ions in 1 mole of a substance. Number 16 we have not done. Number 17 we have not done. We'll do afterwards. Defined, you know. We have done these questions. Let me know in WhatsApp group afterwards if you have any question regarding these ticked ones. I repeat, let me know afterwards. I'm not having my cell phone right now. I will be in contact with you after about 3 o'clock. Okay? Whatever the question that I've ticked, if you have any question regarding this, let me know individually. Okay? Remember second point, whatever new thing that we did today, like that question, that question, this is not included in the test. Last part, see the solution of question number, what was the number? It's the solution of question number 11. Question number 11. Take the screenshot. It's the solution of question number 11, which is not included in the test. From this part, I'm just showing, not explaining anything, that what we did. Definitions, chemical equation we know, combination reaction, decomposition reaction, single replacement, all of these are the theoretical questions you already know. Balancing you did. And after your test, you will submit these two. The intelligent ones, the smart students, the little chemist, they already have done this part also, I know. I will properly put these questions in the Google Classroom as an assignment. Not now, after your test week, I will give you the date of it. So, what will you do today regarding this class? The questions that I have taken, if you have any question regarding this, let me know individually in the WhatsApp group after 3 o'clock. Okay, and these last two which I have read one, this is the assignment. This you will submit after Eid al-Azha in August.